All right, let's talk about one of the biggest headaches in the world of microservices, resilience. We're going to see how we can stop writing all that complex, repetitive error handling code in every single application and instead start managing it centrally, intelligently, and, declaratively. Okay, let's dive right in. So, if you're a developer and you've worked with microservices, I am willing to bet this looks painfully familiar. You're just trying to do one simple thing, right? Make one service call another. But instead, you end up tangled in this web of failure logic.
Yeah, I'm talking about that classic mess of nested try-catch blocks, right? Manual retry loops with, thread.sleep buried in there. But you know what the worst part is? The worst part is that this exact same chunk of boilerplate gets copied and pasted into every single service. Every time you add a new outbound call, you're just duplicating this error-prone code. It's not just messy, it is a huge maintenance nightmare.
There's a name for this. We call it the resilience Rube Goldberg machine. It's just a perfect description, isn't it? You're building these incredibly complex, super brittle contraptions just to handle network faults, and you're doing it inside every single app. And as you can imagine, that creates some serious challenges when you're trying to scale. I mean, just think about the consequences. First, you get this massive code bloat. The same logic is rewritten over and over in Java, then in Python, then in Go. Then your policies get all out of whack. They're dangerously inconsistent. Like, why does service A retry 3 times while service B retries 5? Nobody knows. And that leads to completely unpredictable system behavior. And oh man, trying to actually tune these values across dozens of services, forget about it. It is an absolute nightmare for developers. But what if there was a better way? What if we could get out of this mess? Well, this is exactly where the service mesh comes into the picture. We're going to talk specifically about a tool like Istio, which gives us a totally smarter, centralized way to handle all that network chaos.
I absolutely love this analogy. It just clicks. Think about it. Instead of making every single service, let's call them our drivers, an expert navigator who knows all the back roads and how to avoid every accident, what if we just installed an intelligent central traffic management system for the whole city? That system, that's our service mesh. It manages the flow for everyone, and it applies the same smart, consistent rules across the board.
And this really shows you the before and after in a nutshell. We're moving away from that old world of language-specific, inconsistent code that's just impossible to update. And we're moving to a world that's language-agnostic, where we use declarative YAML to get consistent, platform-wide control. We're basically trading all that complex imperative code for some really simple declarative configuration. It's a huge upgrade. Okay, enough theory. Let's make this real. We're going to look at a super classic microservice interaction. Service A calls service B, which then hits a database. Simple, right? We're going to give this flow a complete resilience makeover, and we'll target 3 of the most common ways things can go wrong. First up, the dreaded slow dependency. So service B is just taking forever to get back to us. Now, without a timeout, what does service A do? It just sits there and waits and waits, holding up resources, maybe causing this huge chain reaction of failures down the line. A timeout is just a simple agreement. It's service A saying, hey, if I don't hear back from you in 2 seconds, I'm moving on. Sorry.
And look at this. This is the fix. It's literally just a few lines of Istio YAML. That's it. With this tiny little snippet, we're telling the mesh, hey, any request going from service A to service B, it has to finish in 2 seconds, period. Now, pay attention to what we didn't do. We didn't change a single line of code. We didn't have to redeploy service A. We just applied a policy to the platform. It is that simple. It's incredible. Okay, next up, the classic partial outage, or, the random network blip. It happens all the time, right? A request fails for some temporary reason. Well, a retry policy just automatically tries that request again. And most of the time, it just works, and nobody ever even knows there was a problem. This is really your first line of defense against all those flaky, transient errors. And guess what? Adding it is just as easy. Another few lines of config, and we can tell Istio, okay, if a call fails, try it again, up to 3 times, and maybe wait a little bit between each attempt. Instantly, our application is way more robust against those network hiccups, and again, and this is the magic part, we still haven't touched a single line of our application code.
All right, last one, the flapping or, completely dead instance. Let's say one specific copy of service B is just failing over and over and over again. Why would we keep sending it traffic? It makes no sense, right? This is where a circuit breaker comes in. It sees this pattern, it trips open, and it just temporarily yanks that unhealthy instance out of the load balancing pool. This gives it a chance to recover. In Istio, the super powerful pattern is called outlier detection.
What's so cool about this is that it's proactive. It protects the whole system from one bad actor. We use something called a destination rule, and we're basically telling Istio, look, if you see 5 errors in a row from one specific pod, just take it out of rotation for a minute, put it in timeout. This is like having automatic healing built right into your architecture. So let's just recap that makeover real quick. We had a slow dependency, bam, we fixed it with a timeout. We had a partial outage, boom, we handled it with retries. We had a flapping instance, we protected the whole system with a circuit breaker. And what's the one thing you have to remember? We did all of this with platform-level config. Not one single line of application code was changed.
Now, it's really tempting to hear all this and think the service mesh is magic and it can do everything. But that's not quite right. To build a truly resilient system, you have to be smart about what belongs in the mesh and what still belongs in your application. So let's do a little reality check. And this is a really, really critical distinction. The service mesh is absolutely perfect for all that network level stuff we just talked about. Timeouts, retrying safe calls, what we call idempotent requests, and circuit breaking. But your business logic, that has to stay in the application. I mean, think about it. You would never want the mesh to automatically retry a charged credit card request, right? You'd end up with some very unhappy customers. Things like rolling back a database transaction or deciding to serve some stale data from a cache if a service is down. That's business logic. That belongs in your code where it has the proper context.
So, with all that in mind, where do you start? The real power of the mesh, the thing that changes the game, is standardization. So let's wrap this up with a super actionable blueprint. Think of it as a starter pack of standard policies you can apply to your entire platform to build a resilient foundation for every single one of your teams. It all boils down to just one number. 5. Just 5 essential policies. If you get these 5 things right, you will dramatically improve your system's resilience right out of the box. Okay, here they are. Number 1, a default timeout for all external calls. Nothing should wait forever. Number 2, a sensible retry policy, but only for safe, idempotent GET requests. Number 3, and this one is so important, a strict no retry policy for anything that isn't safe to repeat, like posts or puts. 4, a global default circuit breaker to protect against failing instances everywhere. And finally, number 5, enforce mutual TLS or MTLS to make sure all your internal traffic is secure by default. That's it. That's your blueprint for resilience. And that brings us right back to where we started, looking at that messy code. But I have one last question for you. I want you to think about your own applications, that tangled boilerplate mess we talked about. Now that you've seen what's possible, what's the first resiliency policy you're going to rip out of your code and move into the mesh? Give it some thought. Thanks so much for joining me.